Hi children, welcome back to the Physical Science Digital class. Children, now we are in Unit 5, that is Human Eye and Colorful World. We learned some concept in the previous session, that is about how the human eye works and vision defects and how to correct the vision defect, and also how the light behaves when it passes through the prism, and as well as we learned about the phenomenon of dispersion of light. So let's take a glance on what we learned, the concepts in the previous session. Okay children, observe here children. Dispersion. What is dispersion? The phenomenon of splitting of white light into different colors known as dispersion. Light is an electromagnetic wave, and the speed of wave V equal to nu lambda. Here the nu represents frequency of the wave and the lambda represents wavelength of the wave. Different colors have different wavelengths and frequencies. White light is a group of different wavelengths. The wavelength range of this visible light is 4000 to 7000 angstroms. Children, what is this visible light? It is an electromagnetic wave which we can see with our eye. So that's why it is known as visible light. In this visible light, what wavelengths are exist? Let's take a look on this picture children. Visible light. In this we have red color, red wavelengths, orange wave, yellow light wave, blue light wave, and indigo light wave, and violet. You can observe the difference between this red wave light and here the violet light. Here the separation between the two crests, successive crests, is greater. That's why the red has a higher wavelength and a lower frequency, that is equal to 7000 angstroms. And likewise orange has a lesser wavelength than the red, that is 6200 angstroms. When you come to the yellow light, so it has a wavelength range of 5600 angstroms. And when come to the green light, which has a 5150 angstroms of wavelengths. And likewise blue 4700 angstroms, and for indigo light 4400 angstroms, and violet, which has a shortest wavelength in this visible light, that is 4100 angstroms. So these are the wavelength range for the visible light. So if you take a first letter from these all the color names, that is read from bottom to top, that is VIBGYOR. So these are known as VIBGYOR, spectrum of visible light. Children, I think you might have seen rainbow in the sky. So the rainbow which is colorful in the sky. Some people observe this rainbow and enjoy themselves. But some people observe this rainbow and they wrote some poems on the rainbow and the beauty of nature. But some people, they think how the rainbow forms, from where these colors are coming. So they think and they try to give some explanation in scientific way how the rainbow is formed. Now in this lesson I am going to explain how the rainbow is formed. Children, in the atmosphere there are millions of tiny water droplets. Whenever the light ray, the sunlight incident on these water droplets, the water droplets disperse all the colors. The sunlight is incident on the water droplets, it disperses all the spectrum of colors. So in our atmosphere there are so many water droplets are present, so that's why all the water droplets disperse all the colors, and those colors appears as a rainbow. Let us understand this formation of rainbow graphically. See here children, observe this picture. Here there is a water droplet. I am taking only single water droplet. So when the sunlight is incident on this water droplet, the light rays are dispersed inside the water droplet and emerge out as all the spectrum of colors. So here the red light and violet light wave. The angle between incoming light wave and outgoing light wave for violet is 40 degrees and for red it is 42 degrees. This angle is in between 0 to 42, but we can observe bright rainbow whenever the angle in between 40 and 42 degrees. The remaining colors are in between these two angles. Before going to explain, we have to know one concept we already learned in our 9th class lesson, that is total internal reflection. So what is total internal reflection? So observe here children. Here, whenever the light ray travels from denser medium to rarer medium, when the angle of incident is greater than critical angle, then the light does not refract into the rarer medium, it just reflects into the own medium. This phenomenon is known as total internal reflection. So children, here to get total internal reflection, so two conditions are to be satisfied, that is incident angle is greater than critical angle and the light has to travel from denser medium to rarer medium. Now I am going to explain formation of rainbow step by step. See here children. Observe here. So whenever the light ray is incident on the raindrop, just draw the interface line at this point and draw the another interface line at the other point, and these two interfaces are angled. So water drop is in spherical shape. It is not in the shape of prism, but still water drop able to disperse the light. Why? Because of the two interfaces which we drawn. Observe here children. The two interfaces lines which we drawn, these points are angled. So due to this reason, the light disperses and traveling through this water droplet and incident at the other end of the water droplet. What happened here? In the second step, here the light ray is incident, the red light and violet, all the colors are incident at the interface. But here the light rays are traveling from denser to rarer medium and the angle of incident is greater than critical angle. It satisfies the condition of total internal reflection. That's why these colors are reflect back into the own medium and traveling along this water drop and incident at the other interface. Now what happened at this surface? See here, it doesn't satisfy the condition of internal reflection. So due to this reason, it is emerge out from this surface. So you can observe here the red light emerge out and the angle between this incident white light and this red light is 42 degrees and angle between incident light and violet is 40 degrees. The remaining colors are present in between these two angles. So like this, in the formation of rainbow, dispersion, total internal reflection and refraction, these three processes are involved. Due to this reason only we are able to see all the colors in the sky. So actually there are so many millions of tiny water droplets are present in the atmosphere. All the water droplets are disperse all the spectrum of light, but still we receive only one color from each water drop. Only one color children. So observe here children. Here the two water droplets I drawn here. So when the white light is incident on the water droplets and they disperse all the light rays, that is all the spectrum of visible light. I am drawing here only two colors, that is red and the shorter wavelength, that is violet. Each droplets disperse all the colors, but still here the person receiving only red wave from the one droplet and the violet from the another droplet, and the remaining colors are from remaining water droplets. So due to this reason, so we receive only one wavelength from one droplet, but there are so many water droplets present in the atmosphere. That's why we are able to receive all the colors. Why we always observe the red color in upper space of the rainbow, and why the violet is generally not visible? Because of our eye is more sensitive to blue, and that's why violet is not visible. So what is the shape of this rainbow? We call it as a rainbow. Bow. What is mean by bow? So it is a shape of like arc. Why we call rainbow? Generally the rainbow is in cone shape. It is a three-dimensional cone shape up to our eye. Are drawn here only the bottom of the cone, and we receive the light rays from the upper part of the cone only. So here the upper part is red one and the inner part is blue region, that is violet, indigo and blue region. So whatever the lights coming from the bottom of this cone are not received by our eye. So only these light rays are reached our eye. Due to this reason, we can see rainbow is like a semicircle. Why the red is upper? Because of we can receive the red light from the water droplets which are outermost in the atmosphere. So we receive the violet light rays from the innermost water droplets. Due to this reason, red light in upper surface and violet in inner surface. So this is about rainbow, children. I think you understood about the rainbow, how it is forms, why will be the rainbow has this shape, and there is some chances to observe the rainbow as in a full circle shape, but it is very complicated. It has to be satisfy some conditions, temperature and angle of vision is very important, and latitude of the place also very important. So sometimes in some places only we can observe the rainbow in a full circle. Okay, children. Now let's move to the next topic. Yeah, what is this? Yeah, sun rising. What is this? The blue sky, white cloud and the red sun. This is sunset. Blue ocean. Children, why the sky appears as blue? Why the clouds appears as white? Is really in that color only? Do they have actually color? So for these questions, we have another one phenomena, that is scattering of light. What is this scattering of light? We learned about light reflection and refraction and dispersion. Now I am going to explain scattering of light. What is the scattering of light? Children, our atmosphere consists so many dust particles and gases. Observe here, children. So 78% of nitrogen gas is present in the atmosphere, 21% of oxygen, 0.9% of argon gas and other gases in 0.1%. In this other gas, carbon dioxide, water vapor, methane and neon gas and etc. all the gases are present in this atmosphere. So children, whenever the sunlight enter into the atmosphere, these light rays are collide with these particles, and there are oxygen molecules, nitrogen molecules and water vapor molecules and carbon dioxide molecules, argon molecules, neon molecules. There are so many particles present in the atmosphere. When the sunlight enter into the atmosphere, the sunlight collide with these particles. What happened? Whenever the light ray, whenever the beam of light is incident on the atom or molecule, it absorbs that light and re-emit the spectrum and re-emit the light. So this process of absorption of light and re-emit the light with different intensities in different angles, in all angles, known as scattering of light. To understand, let us observe this picture, children. So say this is an atom and this is a nucleus. So whenever the light is incident on this, re-emits the light waves with different intensities in all direction. Observe here, here the red light waves are emitted in all directions, but you can observe here these two light waves has the higher intensity and the remaining light waves have the lower intensity. What is mean by this intensity? The intensity of light, nothing but the rate of transfer of energy through unit cross-sectional area, is known as the intensity of light. In our words, to understand intensity, so when you see the sunlight in the mid-noon, you can the light is very bright, means the intensity of light is more. So in the evening, the intensity of light is very less. So you can compare like that. So high intensity means more energy transmission through a cross-sectional area. Low intensity means less amount of energy transmission through the cross-sectional area. So here also the light ray scattered from the atom in all direction have the different intensities. And the angle between this incident light wave and scattered light wave is known as scattering angle. And the intensity of this scattered light is depend on the scattering angle. When the angle of scattering is near to the 90 degrees, the intensity of scattered light is greater. And when the angle of scattering is less than 90 degrees or greater than 90 degrees, the intensity decreases. So here these two scattered light rays are scattered at 90 degrees of angle, and the remaining are with greater than 90 degrees and less than 90 degrees. That's why the intensity of these light rays are very less. Here the children, this is the angle between incident light and scattered wave, that is scattered angle, and this atom is known as scattering center. So what will be the wavelength of the scattered wave? The wavelength of scattered wave is comparable to the size of the atom. Whenever the atom size is very small, it is comparable to the wavelength of violet light region, then it scatters violet. When the size of the atom or molecule is comparable to the wavelength of blue light, then molecule scatters blue light. So when the size of this molecule is comparable to the wavelength of red light, it scatters red light. Observe here children, here the atmosphere consists of nitrogen and oxygen molecules. This green represents nitrogen molecule and the blue represents here the oxygen molecules. When the light rays are incident on these molecules, it scatters the blue rays. Why only blue lights? Because of the size of these molecules comparable to the wavelength of blue and also violet, but the violet light does not visible to our eye because of our eye is more sensitive to blue color only. That's why we receive the blue color. Due to this reason, the sky appears as blue in color. So oxygen, nitrogen, most of the space occupied in the atmosphere. Due to this reason, whenever the sunlight entered into the atmosphere incident on these nitrogen and oxygen molecules, it scatters the blue light and also violet. We receive the blue color. That's why the sky appears as blue in color. Then why the clouds are appears as white? Because of the clouds consist of so many tiny water molecules. Why it is appears as white? Observe here children. So whenever the light is incident on this molecule, it scatters the wave which has a wavelength comparable to the size of this atom. Whenever the size of the atom is increased or molecule, it emits higher wavelength also. Likewise, again and again, if you increase the size of the molecule, it emits the light waves which are comparable to the size of the molecule. So observe here children. So how the molecule size is going on increases, it scatters the wavelengths which are comparable to the size of the molecule. Whenever it able to scatters the all the colors, it is appears to be white. When we receive the all the colors from the molecules, then it is appears to be white. Observe here children. So here the size of the molecule is huge, so it can scatter the all the colors, then it appears as white. This is happen in the cloud. So the cloud consists so many number of water particles. So water particle size is greater than oxygen and nitrogen molecule. Due to this reason, the water droplet can scatter all these colors. That's why they appears as white. When we receive all the colors at a time, it is appears as white. So the combination of all the colors gives the white light only. So we have an activity in our textbook. The scattered wavelength is depend on the size of the molecule or atom. Yeah, observe here children. I took some sodium thiosulfate and add to the sulfuric acid. When we add sodium thiosulfate to the sulfuric acid in the presence of sunlight, the sulfur molecules are start formed. Initially, these are in small size, that's why it is appears to be a blue in color. The size of the molecule is going on increases, then the liquid is appears to be white. Observe here children, here before the reaction, so whenever the reaction starts, it is appears to be blue. After completion of reaction, so it is appears to be white because of the sulfur molecule sizes is increased. Whenever the size of the scattering atom is increased, it scatters all the colors, that's why it appears as to be white. So children, this is the reason behind the why the sky is appears as blue, why the clouds are appears as white. And we can see sometime the sky is appears as white in the mid-noon. Why it is appears as white in the mid-noon? Because of when we see the sun vertically, what happen, all the colors are receives our eye. Due to this reason it is appears as white in color. But when we see the sky a little bit angled, only the blue colors are receives our eye. That's why the sky is appears as blue. So the intensity of this blue color and white will be different in different direction. This is only because of scattering angle. As scattering angle is less or more than 90 degrees, then the intensity of light will be less. When the scattering angle is 90 degrees, that's why when we see the sun vertically in upward direction, that is at 90 degrees, we receive the high intensity light waves. So it will be harmful to our eye. It may damage our retina. Why the sun is appears as red in the sunset time and sunrise time? So in the mid-noon it is appears as bright white and somewhat in yellow shade also. So why the sun is appears as red in the evening or in the morning? So observe here children, observe this slide children. Here whenever the sun is in the mid-noon, it is exactly vertical to us. So that's why we receive all the light rays at 90 degrees, and all the light, when we receive all the colors, it is appears to be white. But when it is near the horizon, that is at the time of sunset and sunrise, or in the morning and evening, the sun is near the horizon. So when it is near the horizon, the light rays coming from the sun entered into the atmosphere, and it scatters the light rays, the red and almost orange, red and orange region light rays are reaches the earth, and the remaining blue region light waves are escaped from the atmosphere. So here we are receiving only red region wavelengths, that's why the sun is appears as red in color, and the remaining colors are escaped from the atmosphere. They are also scattered, but they are not reach our eye. They escape from the atmosphere. Due to this reason, we are not able to see those colors. Only we are able to see the range of this red and orange. That's why the sun is appears as red. Children, about this scattering, Bharata Ratna Sir Chandrasekhara Venkat Raman won the Nobel Prize in 1930 for discovering the scattering of light through liquids, known as Raman effect. We celebrate National Science Day on 28th February each year because of on the day in 1928, on February 28, C.V. Raman discovered the scattering of light through liquid. That's why we celebrate National Science Day on that day. He is the first Indian who receives the Nobel Prize in Physics. Take a look on the concepts we learned in this session. Rainbow formation involves dispersion, total internal reflection and refraction. We observe bright rainbow when angle between incoming and outgoing rays is near the maximum angle of 42 degrees. The process of re-emission of observable light in all directions with different intensities by atom or molecules is called scattering of light. The angle between incident light and scattered light is known as scattering angle. The intensity of scattered light varies with angle of scattering. The intensity of scattered light is maximum at 90 degrees angle of scattering. The scattering light wavelength depends upon the size of the molecule. Oxygen and nitrogen molecules have size comparable to the wavelength of blue light. That's why they behave as a scattering center for the blue wavelength. Due to this reason, the sky appears as blue. Sir C.V. Raman won the Nobel Prize in Physics in 1930 for explaining the phenomenon of scattering of light by liquids known as Raman effect. Children, for well understand, just to try to answer these questions, children. Explain formation of rainbow in your own words. Why does the sky sometimes appears as white? The intensity of blue light is non-uniform throughout the sky. Give reasons. What is scattering? Try to answer these questions. Then you can understand the lesson. Then you can understand the concept. For better understanding, please visit the SCRT website, that is scrttelangana.gov.in. There are worksheets given in this site, and try to solve all the assessments which are given in the site, and try to improve yourself. If you have any doubts, please communicate with your subject teachers and they can clarify your doubts. Children, thank you.